Okay, here we go. Part 2 of this review. Start on 21, left off on 20. Hopefully the last video helped you out. So what we're going to do here, we're going to simply divide it. So we just have to simplify 6 over 9. That gives me 3 goes into both. We get 2 over 3. So what we're going to do, we're dividing. So if it's the same base, we're going to subtract exponents. So the a is here. 3 minus 2 gives us 1. We have b and b. Okay, 2 minus 4 gives us negative 2. And here we have the c. There's a 1 here. So negative 1 minus 1 gives us negative 2. Now, negative exponents, we just push to the bottom. So we're going to get 2a all over b squared c squared. Okay, so that's what we get. Oh, don't forget the 3. 3. Alright, so that's what we get here. Right, the negative 2 and negative 2, they both go down. Okay, number 22. All we're asking here is what is a domain restriction. So we know with a fraction we cannot divide by 0. Therefore, we have to see when this denominator is going to be 0. So x squared minus 9 cannot be 0. At 9, x squared cannot be 9. Square root. So that x cannot be plus or minus 3. Well, luckily that also works here. If we solve this, we get positive 3, which is already included in our answer. 23. All we're doing here is comparing our degrees of the numerator and denominator. Okay, so that when we're looking for our horizontal asymptote, we compare the degrees of the numerator and the denominator. So in this case, m is equal to n. Therefore, we divide the leading coefficient with the leading coefficient. Y is equal to 3 divided by 1, which is 3. So y equals 3. It's horizontal. My vertical asymptote we set denominator equal to 0 and solve. So x squared minus 16 equals 0. 16 square root x equals plus or minus 4. Right? So we have our answer here and here. Okay, moving on. This next problem, 24, is very similar to what we just did, just a different equation. So we'll look at first, we'll look at each horizontal asymptote first. So the degrees, once again, m is equal to n, 1 and 1. So y equals 3 divided by 1, which is 3. Horizontal, my vertical asymptote. So the denominator equal to 0 and solve. Okay, pretty simple. 25, what is the domain of the function? So once again, domain of the function refers to the x values in a fraction. We cannot divide by 0. So look down here, x squared minus 1 cannot be 0. That's just x, plus or minus 1. So we'll use this, we'll say the domain is all real numbers, but however, x cannot be equal to positive or negative 1. Looking at 26, we're just going to say how many solutions does this have. So to start solving this, we'll square both sides. So what this gives me is x minus 2 squared equals 3x minus 6. When I expand this, I get x squared minus 4x plus 4 equals 3x minus 6. I'm going to bring both of these over. So we get x squared minus 7x plus 10. So we go to factor this, we're going to get x minus factors of 10 that add up to 7. So x minus 5, x minus 2, I already see that those are going to be, that'll lead to my solutions. So we have two solutions. Okay, they're not asking us for what the solutions are, they're just saying how many. 27. First thing we do here is write this as a big square root. The square root of 54 divided by 2. Well, 54 divided by 2 is the cube root, rather. This gives me 27. The cube root of 27 is 3. Okay, we have to evaluate that. So, first of all, negative exponent simply means we write it as a fraction. Exponent becomes positive. Now we have a fraction as an exponent. That refers back to radicals. So the denominator is the index, the numerator is the exponent. So the square root of 9 is 3. And 3 to the third is 27. Transformations of this function. So down here, this is my k value, this is my h value, this is my k value. So h is equal to what? Negative 2. K is equal to positive 1. So this tells me that it moves 2 units left, 1 unit up. 30 divided both by 9. Cancel. We get cube root of x minus 5 equals 2. We want to get rid of the cubed root, so we have to cube both sides. We get x minus 5 equals 8. 2 thirds 8. Add 5 to both. X gives me 13. Don't have to check that. We got one answer. We're good. I'm going quick, but this is a video, so you guys can always just pause it if need be. Alright, solve for x. So we square root of both sides. We just square both sides. We get 8x minus 5 equals 6x minus 3. Bring over the 6 and bring the 5 over the other way. Those cancel, so it's plus 5 here. Minus 6x there. So we get 2x is equal to 5 minus 3 is 2. X equals 1. This equals 1. $32, so we want to square both sides. 2x plus 1 equals, when I square this, I get x squared, double the 7 minus 14x, and square the 7 plus 49. So what I have to do next is bring both of these over. So I have minus 2x and then minus 9. So what I get is x squared minus 16x plus 48 equals 0. We factor this. Factor the 48 that add up to 16 is 12 and 4. Okay, negative 16, they both have to be negatives. We solve this, we get x equals 12. Here x is equal to 4. Now we have to check. So if I plug a 12 in, let's just look. So 2 times 12 is what? 24 plus 1, 25. The square root of 25 is the same as 12 minus 7, which is 5. Okay. And I plug a 4 in. So look over here. If I plug a 4 in here, we get 4 minus 7, which is negative. And we get negative 3. The square root of something can never be a negative number. Alright? So it cannot be 4. That is an extraneous solution. you're careful with that. Let's see another one next, number 33. Square both sides. 6x plus 1 is equal to x squared minus 2x plus 1 minus 6x minus 1. Cancels. Alright, so when we solve this, it's a little bit different. We're going to factor out an x. Okay. Same idea here. Let's plug in 8. 48 plus 1 is 49. The square root of 49 is 7. 8 minus 1 is 7, so that works. Plug in the 0 right here. 0 minus 1 is negative. Nothing can make this equal to a negative number. This does not equal 0. This is an extraneous solution. Okay. So, shifted 4 units left is my h value. 6 units up is my k value. Well, remember it's opposite. So here we're going to have f of x is equal to, left under here really means plus, and then 6 up is plus 6. Right? Pretty simple. Domain and range of this function, we cannot have a negative under the radical. We talked about this before. So we can't have a negative under here, so I say x minus 5 must be what, greater than or equal to 0. Add 5 to both. X is going to be greater than or equal to 5. So my domain, small numbers, x greater than or equal to 5. My range, since a is positive, this function is going to be above 0. So all the numbers, y is greater than or equal to 0. If a was negative, this would be less than or equal to. Alright, otherwise it's pretty easy to describe the transformations with h and k. There's no a. So that means 1 unit to the left. And the k is negative 1, so it's going to be 1 unit down. Right. Describe whether, decide whether the function represents exponential growth or decay and explain why. Right, so in growth and decay, we have to look at our b value, which is this. If it is above 0, it is growth. If it is in between 0 and 1, it is decay. So clearly this is in between 0 and 1. Right, in between 0 and 1. That means it is a decay function. Pretty easy there. Okay, last 3. This is the most familiar. I'm going to rewrite all of this as a in logarithmic form. So in this case, the base is 3. So log base 3. It's always equal to the exponent, meaning this has to go next. Equals the exponent. And that's what we have to do there. 39, we have a fraction. And we're changing it to something that's not a fraction. So therefore our answer has to be negative. 2 to what power? So 2 to what power gives me 8. Well, 2 times 2 is 4, times another 2 gives me 8. So 2 to the 3rd power, so negative 3. And here we're going to simplify this. This comes up top. We have log x squared plus log of 2. Well, addition means multiplication, so we just multiply this together to x squared. That's what we get. Right, that is it for the review. Good luck. If you have any questions, feel free to email me. And then, of course, to enjoy the summer.